A steel W-shaped beam is simply supported over 36-foot span subjected to a uniformly distributed factored load. The compression flange is laterally braced at 1/3 points along the span. Fy is equal to 60 ks. Cb is equal to determine the maximum factored uniform load the beam can safely support. The beam is provided, it is in uniform distributed load, it is laterally braced, dividing the whole span into 3 mini spans, and the beam itself is W21 by 57 and the length of the beam is 36. So using this data, they're asking us to find the maximum factored uniform load WU. So if you search this number W21 by 57 in your FE reference manual, you'll directly come to page number 286, okay, where there is a graph between available moment 5 Mn and unbraced length. So always remember that whenever they give you W U or Mu, that is nothing but factored load or factored moment. Mn or Wn, that is the unfactored load without the safety or unfactored moment. So using the 5 Mn and also unbraced length is nothing but total length by divided by total number of spans. Total length is 36 divided by 1, 2, 3 spans, that is 12 foot, 12 foot, 12 foot. 12 foot is your unbraced length. Using this data, if you map in this curve, W21 by 57 curve is going all the way from the top, touching the x-axis at 14, at the point 14. So if you put the unbraced length at 12, it is going to strike at approximately 345. 5 Mn is equal to 345. So 1, 2, 3, 4, 5, 15. So each of this point is going to be 3 points. Okay, based on this, you can accurately get your 5 Mn value. So approximately 345. Now 5 Mn is equal to 345 is obtained. At the same time, the only thing you got to remember for this problem is 5 Mn is equal to maximum moment. If you go search for maximum moment in FE reference manual, on page number 139, maximum moment for simply supported beams is provided. This particular case is this one over here, okay, right next to 139. This is the uniform distributed load case. Every other case is very, very different from the given problem. So for this one, the maximum moment is provided by Mmax is equal to WL square by 8. Simply put, WL square by 8 will be equal to 5 Mn. So using this data, 5 Mn is equal to WL square by 8. Rewrite the W value. W is equal to 5 Mn times 8 divided by L. So 5 Mn, we already got it from the graph as 345. L square is 36 square. Once you substitute these values, you will get the W value as 2.12 kips per foot. For your understanding, I have clearly labeled the whole problem as 1, 2, 3. Okay, all of these are clearly labeled. So when you check the notes, it's already present.